I want to demonstrate some of the capabilities of Graphica3D. One of the main strengths of this application is understanding complicated mathematical notation. Now here we have a set of equations which describe a particle in a 2D harmonic oscillator potential, where hx of z and hy of z are Hermite polynomials, and we can change nx or ny, changing the degree of these polynomials. So if I wanted to visualize this, I just click the button and I'd see already that it's very tall. So I go to settings, I go to view, I click scale mode, and then I click it again, and now I get it to scale. And I might want to change the axes color, and I could change the degree to 3. I see that instead of a quadratic, it's now a cubic. Change the degree to 4, and I can see it's a quartic, and so on. I'll change it back to 2 for now. Now I can go back down in hy and see the same thing, and here we have the wave function. This is the normalized wave function for the particle, and if I show it on screen, we can see that it's just a 2D scalar field. Now I want to change the ranges of this because there's a lot of wasted space here that doesn't really show us very much. So I'll narrow it down to just 3, and I'll reduce the number of data points because 600 is too much for now. So I'll change it to 250. So now we can see the wave function, and if I wanted to, I could change this to wireframe or just to points, but I'll keep it as a surface for now. And I could change the color map if I wanted to, maybe to jet, which is more like a heat map, but I'll keep it as my favorite winter. What we can do is we can change variables that affect functions within functions and see how that updates it. So I'll change this to 3, and we can see that immediately our wave function has updated to represent that new value. I can change it to 4, it updates again. And now I can change this ny to, let's say, 8, and again I see that it's updating in real time. Now I'll just hide that, and now this is the probability density, showing that at any point xy, what the probability of the particle being there is. Now again, there's a lot of wasted space, so I'm going to reduce this down to -2, 2 in all directions. And I'm noticing now that I've made it smaller, the font size is a bit big, so I'll just reduce that. So I'm not a fan of this color map, so I'll change it to, I'm not a fan of that either. I'll change it to rainbow. Here we can also see that if we change other variables, we can see that this is dependent on alpha, and this is dependent on our wave function here. So if I change alpha, this plot will update as I slide alpha. And we see that it gets more spread out when alpha is smaller and more closer in when alpha is bigger. And then just below this, we have the probability current or flux density, which is a 2D vector field describing the flow of probability. Now you might notice that it's not particularly easy to see what's going on, so I'm going to make all the vectors smaller and make more of them. And I'm going to reduce the ranges again. So now we can see more clearly what's happening. We have these specific points of probability flowing towards these, I guess, sinkholes, you could say. If I make them even smaller and zoom in, we can, it's a lot clearer. So then if I go back to here, we can see that these sinkholes are lining up where the probability density is very high, and I can change the opacity of this to maybe 0.8 just so we can see the vectors a little bit better. We can see that they indeed are pointing to these bumps on our plot. So this demo isn't particularly about this specific wave example, but showing that Graphica3D supports lots of complex notation which can be inputted via latex commands. So I could do \sum and I get a summation, you can see here at the bottom left, or \int and I get an integral, things like that. You can use latex commands, or you can, at the top right here, you get a virtual keyboard and you can click through these and see the different symbols that you can get and use.